Hello, hello, hi everyone. Is anyone there? And am I audible? Please respond if I am audible. Okay. So, hi everyone. My name is Pradyumn, and today we'll discuss the problems A to E from today's CF round, which was Goodbye 2025. And before we begin, I'll tell you about our courses at TLE Eliminators. So, if you are someone who is stuck at solving just one or two problems per contest, then our self-paced courses are what you need. We have structured the program into four different levels so that you can start from wherever you are: beginner, pre-intermediate, intermediate, or advanced. You will learn the most relevant CP concepts through video lectures, followed by carefully curated practice problems combined with guided hints and video solutions that help you understand the why and not just the how. We believe in helping you build real intuition. If you need more support, then you will get instant doubt support from our higher rated mentors, so you're never left stuck. And beyond just learning, you will enjoy leaderboards, progress tracking, internal contests, and PCDs to keep you consistent. And if you're not sure that which level you should choose, which level is correct for you, then you can watch this video right here, which will help you decide how to choose a level. And in case you are still not sure about a level, then you can watch the specific video for that level. Like you can open this level right here and you can watch the video for this level, which will explain the prerequisites, outcome, difficulty, and the topics taught. Okay. So, all right. So let's start now with the PCD. Um, so this was the contest. I solved till D in the contest. I could not solve E, but I'll discuss it because I asked this like I got a solution from somewhere else. Okay. So we'll start with A. Last Christmas, your friend Fernando gifted you a string S consisting only of letters Y and M, which are yes and no. You can repeatedly apply the following operation on S. Choose any two adjacent characters and replace them with their logical OR. Formally, in each operation, you can choose an index I from 1 to Si minus 1, I mean the length of S minus 1, and remove the characters Si and S of I plus 1, and then insert a single Y if at least one of them is Y, and if both are N, then insert N. After the operation, the length of S decreases by 1. Unfortunately, Fernando doesn't want you to combine yes or yes, as he's experienced trauma. Okay. Determine whether it is possible to reduce S to a single character by repeatedly applying the operation above without ever combining two Ys. Okay. So it is a simple problem that they are asking. Just a minute. I forgot to connect my writing pad. Wow. Okay, and now my pen is nowhere to be found. So just a minute. I will get back to you. Okay. So A is supposed to be like we have been given Y and N, a string of Ys and Ns. And what we can do is we can select any two indices and combine them with their logical OR. So no or yes is yes. Yes or yes is yes. And no or no is no. Right? And we want to combine all of these into a single letter. Yes, we want to combine all of these into a single letter without ever combining two Ys. Like we don't want to combine two Ys. Okay. So can we do that? Okay. So it is very simple that okay. Let's say you have a string yn yn, right? So if you combine two n's, then you will get an n, right? So that's how you can reduce one of the n's, right? But if you combine y and n, okay, then you will get y, right? So this n gets reduced essentially, right? This y doesn't get reduced. And if you combine y and y, like let's say there were y here, and you combine them, then you can reduce a y, okay? But they are saying that you cannot combine two y's, right? You can never combine two y's. You can only combine either yn or nn, right? So if you combine nn, you will delete n, and if you combine yn, you will still delete n, right? So you can never delete a y. Like if you never perform this y operation, you can never delete a y. So the number of y's that are there originally in the string, there are four y's, right? So whatever you do, number of y's will remain four if you never combine two y's, okay? Because even if you apply the operation here, then also this n will get deleted, right? You have to replace this with a single y. So essentially this n is deleted, but you can never delete this y unless you combine two y's, right? So that's my point, that initial number of y's, initial number of y is equal to the final number of y, right? So if you have two or more y's initially in the string, two or more y's, then definitely there will be at least two y's finally. Like you cannot get rid of them. So you cannot really make the size of string one. Like the problem is that you need to make the size of string to one, right? You just need to combine all the letters and make it one without ever combining yy. So it is not possible if there are more than one y's in the string, okay? So if there are, like, if the count of y is greater than 1, then the answer is no, right? And otherwise, if the count of y is 0 or 1, then can you combine it? So okay, if it is 0, then of course you will combine it because there are all n's. So there is no 2y, like there's no possible way that you will combine two y's, right? You can combine these two first and then these two and then these two and so on. And if there is only a single y, then also you can just combine everything and you will never get two y's, right? Because there is only one y in the string. Like the only illegal move to do is combining two y's, right? But there aren't even two y's in the string. There's only a single y. So you will never do this move. So you can just do whatever you want with a string and finally just bring its length to one. Like if you have n, y, n, then you can just combine these two. So it becomes this. Then you can combine these two, it becomes y. Then you can combine these two, it becomes y, and these two. And then you can combine these two, it becomes single y, right? So yeah, um, that's how it works. So finally, the answer is that if there is more than a single y, then the answer is no. And if there is only if there are no y's or there is only one y, then the answer is yes. Okay. All right. So this should be pretty clear. I will show the code. In the code, there is nothing much. I just used count function. So string s cin s, if count of y is greater than 1, then cout no, otherwise cout yes. Okay. So I hope it is clear. Just give me a yes so I can move on to the next problem. Okay. So B was, let's move on to B. B was impost or sus. A string W consisting of lowercase Latin letters is called suspicious if and only if all the following conditions hold. the letter S appears at least twice. For every occurrence of the letter U, the two nearest occurrences of S are the same number of characters away from the U. After watching you finish a string task, your friend aka your friend Akka has given you a string R consisting only of letters S and U. You can perform the following operation on R. Choose an index I and set Ri to S. Determine the minimum number of operations needed to make R suspicious. Okay. So what they are saying is that for a given string which has U and S, so U S U S S U S U. Okay. So let's say this is a string. So what they are saying is for every U, let's say this is a U, right? So for every U, the two nearest S's, okay, the two nearest S should be at equal distance to the U. Okay. So for this U, the nearest is this one, and this one also nearest. So the two nearest S's are at distance of 1 to this U, so it is fine. So like this U is okay. Okay. Then for this U as well, the two nearest S are this one and this one. Okay, so this U is also fine. But for this U, the nearest S is here, and second nearest S is this at a distance of 3. So distance 1, distance 3. So this is not good, right? Therefore, this string is not suspicious. So this string is not valid. Okay. So we want to figure out that what is the minimum number of U that we need to change so that the string becomes suspicious. Okay, fine. So what can we do? Now just look at this problem carefully. Okay, so if you break it down, like what I'm saying is, if you look at the definition of this suspicious string and just you can actually simplify it. Okay, so basically it is that for every u the two closest s should be at the same distance to the u, right? So like basically for each u, let's say this is a u, so every s, the closest s should be at the same distance. So basically one of them has to be on the left. Let's say it is here, like the closest s is this one, and for on the right side also the closest one is this. So if these two are closest, then that means that here there must be u, right? Because in the string there is only s and u. So for this u, the closest two are this one and this one, right? So this u is fine. But now you see, for this u, the closest one is this, right, at distance of 1, and the second closest is either this one, like either this one which is at a distance of 3, or maybe it can be like this one also. If there's an s here, then it can be that this s at distance of 2, that might be second closest. But in either case, like either this is the second closest or this one is, but in both the cases this u is not fine, right? Like basically I want that for this u, the closest two s's should be at equal distance, right? So if at in this side there is an s at distance 1, then at this side also there should be an s, right? That's why this is not a good u, and therefore this string is not suspicious. Okay. So you can see that like you can simply see that you cannot have more than a single u in a block. That is the thing. Like here, let's say you have a block of u's, u. Let's say 5 u's you have, and both sides there are s. So for this u, it is fine. Like the closest two s's are at equal distance. But for the other u's, like for this u, this is the closest, and second closest is farther. At distance 4, this is at distance 2. So it is not fine. So basically, you cannot have a block of u's. In fact, you cannot even have two u's. If you have two u's, then also it is not fine, because for this u at distance 1 and this is at distance 2, so this u is not fine, right? So basically my point is that all blocks of u in the string must be of length 1. Okay, that is one condition. And also one more thing is that um, there has to be s on both sides of a u. Like, see, this condition is that all the blocks of u in my string must be of size 1. Like, you cannot have two contiguous u's. You cannot have like this. So in this case, the size of this block is 2, right? This is one block and the length is 2, right? But there is one more condition. Like, you cannot even have this. Let's say USS. Okay, so even if in this string every block of u has size 1, but still this is not fine, because this u, there is nothing to the left of it, right? Like, there's only a single s to the right of it, so the closest one is this, and second closest is this one. So they are at distance 1 and distance 2. So that is also not fine. So basically, you need that for every block of u, there must be an s to the left of it and s to the right of it, right? This is one condition, that all blocks of u in the string must have length 1, right? And the second condition is that every u must have s on its left side, on its left and its right. Okay, so that just means that the string cannot start or end with u, right? Like, if it doesn't start with u and doesn't end with u, that is, it starts with s, then some u, then some ss, then a u, then an s, then a u, then an s, right? So if it doesn't start and end with u, then of course all the u's will have some s to the left and the right of it. Okay, so that is the entire thing, that this is your um, final type. Like, the final condition is that the like all the blocks of u's should be of length at most 1, and also the string should not start or end with s, right? So let's say in the input you have been given some string, right? So first of all, just make the start and end of the string to be s, right? That is one thing, because you need s here definitely. So if there is u here, you need to change it. Okay, so that's one thing you will do. And then what you will do is, you will just look at the string. Okay, you will look at the string, and for every block of u's, okay, like, let's say there is some string s u u u u s u u u su. Okay, so there are three blocks, right? There is this block of length 4, this block of length 3, and this block of length 1, right? So what you can do is, you can change a u to an s, and then you can perform this operation, right? So what is the least number of operations that you can perform on this block, so that there is only a single u, like there are no consecutive u's? So what is the minimum number of operations? You can change the u to an s, right? So if there are 4 u's contiguously, you can just change alternate. Like, you can change every other one, like just change these 2 u's to an s. So now the remaining u's, they are only a single character, right? And let's say from this 3, you can simply remove this one. I mean, you can change this to an s. So these 2 u's will be a single character, and this is already single, so it is no problem. So like, if you have if you have a block of k u's, okay, let's say there are k u's in here, then you can just change every alternate one, like this one, and this one, right? So basically, the floor of k by 2, like you will need to change floor of k by 2 u's, right? So you can just iterate over all the blocks of u's and add up this value, block length upon 2. That many operations you will need to perform, and plus the starting and ending one, right? So that is the entire thing. Like, just first step is to just change the starting one and the ending one to s, and then the internal ones. Just count the block length and do accordingly. Okay. If we brute force and run the loop from 2 to minus 2 and check if the current character is u or not, and if yes, then check the previous and current and first last separate. Number of u divided by 2. I don't think that will work because there is this like floor function, right? So let's say you have s, then 3 u's, then s, then 3 u's, and then s. Okay. So my formula gives that these three blocks, so 3 by 2, which is 1, and then these like block of length 3. So again 3 by 2, which is 1. So the answer is 2, right? But if you do number of u's upon 2, then it will be 6 upon 2, which is 3. So it is wrong. Okay. I just looped and make u into s and count in the steps. Yeah, that works. Like, that is fine. Like, if the last character is u, then you will change, like if the current one and last one both are u, then you will change the current one to an s, right? That is fine. Or you can just count the consecutive pairs of u. Um, yeah, like that is the same thing, but you need to be careful. Like, basically the same logic applies, but you need to be careful to not do overcounting. Like, you can, let's say in the code, if you count this as consecutive pair, then this one also, then this one and this one, then you will get another wrong answer, right? Difficulty of D, um, I guess 17, 1800 or something. So any doubts in B, guys? Just let me know. Meanwhile, I'll show the code. Hmm. So here I have string s c in s, int ans equal to 0. If the first element is u, then change it to s and ans plus plus. And if the last element is u, then change it to s and ans plus plus. Right. Then what I do is I make this vector, okay, which is like I am just compressing the string into numbers, right? So like, let's say the string starts with s, right? So let's say there are some s's, then there are some u's, then there are some s's, then u's, then there is some s's, right? So for this string, like for this string, I'm making a vector of pair. Okay. So for this string, the vector that will be made is basically s comma 3, then u comma 2, then s comma 4, then u comma 4, and s comma 2. So this is the vector that is being made. Okay, like from this string I am making this vector, that there are first 3 s's, then there are 2 u's, then there are 4 s's, then there are 4 u's, and there are 2 s's. So then I can just iterate over the odd indexes. Like in this vector I can iterate over the odd indices, like 1 and 3, and then I can just take this number by 2. Okay, so what I'm doing is I initialize this vector with s1, like because the string starts with s, I am initially inserting only s comma 1. Okay, then I iterate over the string for int I equal to 1. Like I skip the first character, right? Because the first one is already inside the vector. So for int I equal to 1, I less than s dot size, I less than s dot size I plus plus. If s of I is equal to v dot back dot first, that is, if the last element is the same as the current character, then I will just increment the count, right? Otherwise, I'll insert this s of I comma 1. Okay. So like to make this vector, I basically initialized it with s comma 1, right? Then I look at this character, it is also s, so I made this 2. Then this is also s, so I made this 3. Then this one is not same as s, so I just push back it u comma 1. Then I look at this, so this u and this u are same, so I make it 2, right? And so on, this goes. So I make this vector, and then finally I just iterate over the odd indices. For int I equal to 1, I less than v dot size, I plus equals to 2, and ans plus equals to v of I dot second by 2, and print ans. Okay, so this is what I can do. Like, no, I wasn't able to solve E, I guess, but it was not that hard actually. Okay, I'll move to C. C is called first or second. There are n children standing in a line where the niceness of the ith child is AI. Santa is deciding which children to belong on the nice list and which belong on the naughty list. An integer x is initially set to 0. Santa will perform the following operation exactly n minus 1 times. Choose the first or second child in the line and remove them from the line. Let W be the niceness of the chosen child. If the first child was chosen, add them to the nice list and add W to X. If second child was chosen, add them to the naughty list and subtract W from X. After all the operations, exactly one child remains unassigned to a list. Determine the maximum value of X that Santa can obtain after all inverse operations. Okay. So what they are saying is that we have an array, right? We have an array A1, A2, A3 up to AN. Okay. And basically what we can do is, like, there are first two elements, right? These two are the first two elements. So either we can, initially we have a variable called x equal to 0. So either we can do, like, we can add a1 to x and delete a1, or we can subtract a2 from x, like x goes to x minus a2, right? And then delete a2. So the first two elements would become a1 and a3, right? So we can perform this operation n minus 1 times, and in the end only a single element will be left in the array. And finally, whatever is the value of x, we want to maximize that. We want to maximize the final value of x. So we want to print that what would be the final value of x. Okay. So my question is that why don't we do this? Like, First of all, I thought that if you want to maximize the value of x, then why would we even subtract an element? Like, why would we ever subtract an element, right? Like, we would just add it, right? We will just keep doing first, and so on. Like, just add a1, then these two are the first two elements. So just add a2, then add a3. Then I noticed that they can be negative also. Like, the elements can be negative, right? So that is the issue. And also, okay, like, just basically the elements can be negative. That is the point. So maybe it is better to subtract them, right? Like, the negative elements ai, it is better to do x goes to x minus ai rather than x goes to x plus ai, right? So preferably we want that all the negative elements should come with negative sign. Like, we should do the second one for the negative elements and the first one for the positive elements, right? We want that, like, ideally we want that. Okay, like, let's say if we have this array minus 4, 2, 3, minus 6, we have minus 4, 2, 3, and minus 6. So ideally what we want, like, the thing is that either every element, like, for each element, let's say for this element, either it comes with positive sign in our sum or with negative sign, or it doesn't come, right? Like, it might be that it is the last element to be left. Okay, so yeah, so my point is that either it is the positive or the negative, or it doesn't appear in our sum. So preferably what we want is all the positive elements come with plus sign and all the negative elements come with minus sign. That is the maximum that we can go, right? But is that possible? um like, so then I thought that what all combinations are possible. Like, see, we cannot arbitrarily assign plus and minus, right? Like, if it was up to us, like, if it was in our hands that we can just assign whatever we want, either minus or plus, then we would assign it like this. But that is not in our hands, right? Like, we have to follow the procedure that they have given, that in the array we have to either do, like, we have to choose the first two elements and either add the first one or subtract the second one. So then I thought that what is the number of possibilities, like, what possible signs can I give to the array? Like, for example, if I have a1, a2, a3. Okay, so can I give this signage? Like, if I want plus for a1 and plus for a2, and I don't want a3 to appear in my sum, that is, I want my x to be a1 plus a2. So is it possible? Yes, it is possible, because we can simply look at these two elements and take out the first one. Okay, so a1 is there with plus sign, and then these two are the elements. So I can just take out a2. So it is the first element, and so plus a2 comes there, and a3 is the remaining one, right? So this plus plus and cross is possible. Then let us see that is plus, minus, and cross. Is this possible? Like, I want a1 with plus sign, a2 with negative sign, and a3 with like, I don't want a3 in my sum. So is it possible? So yes, again, it is possible, because we can simply, what we can do is we can remove a2 first. So it is second element, right? So it will become minus a2, and we're added to our sum. So then the array becomes a1, a3, and then we can choose the first one. So minus a2 plus a1. So this is how my x will become minus a2 plus a1, right? So this is possible. So that's what I am doing. Like, right now I am thinking that which configurations are possible to make, right? So I saw that plus plus x is possible, plus minus x is possible. Then what else? So let us think now that how to determine that it is it possible or not. Okay. So which ones are possible and which ones are not? Let us think about that. So one thing to notice is that, let's say we have these elements a1 to an, right? A1, a2 up to an. So first of all, my point is that a1 can never come as negative sign, right? Like A1 can never be negative. Okay, because for it to be like for us to be negative, it has to be second element, but it is already left, like it is already at the first position. So of course it cannot go to the second position, right? So A1 can never be negative. It can only be that it is positive or it is cross. That is, we are leaving it, right? So that is one condition. A1 can never be negative. One more condition is that only one element, only one element can be left, right? Like that is one more condition, obviously, that is in the problem itself. That finally only one element will be left. That is, like in our plus minus cross or plus plus cross, this cross can come only once, right? Okay. Either it has to be like every element has to be plus or it has to be minus, except for only one element, right? And yes, exactly one element actually. Like we have to skip one element. So exactly one element has to be left. Okay, has to be left. Okay. So now, guys, just let's think about this part. Okay. So we have, let's say, five elements. Let's say I have plus, minus, cross, minus, plus. Like I want my signs to be like this. Like I want that A1 should come with a plus, A2 should come with a minus, A3 should not come, A4 should come with a minus, and A5 with a plus. So is it possible? So let's think about it. First of all, A2 I want with a minus, right? So of course I will delete this A2 first. Okay. So now I have A1, A3, A4, and A5. So I don't want A3. Like I will never delete A3, right? So now only option is to delete A1, right? And of course A1 is the first, so I got plus, and that is fine. So now I have A3, A4, and A5, right? Now I can delete A4 only because I don't want to delete A3. So I'll delete A4, and A4 got with minus sign. That is fine. So now I have A3, A5. So now I have to delete A5 only. And so this A5 got with minus sign, but I wanted plus, right? So that is not, there's a problem. Like, how do I make this A5 to a plus sign? I can't, right? Because this A3 is blocking the first position. Like if I want A5 to be the plus sign, then it has to be here, right? It has to be on the first position, but A3 is blocking it, so it cannot really be the plus sign. So my point is that, let's say you have this array up to an, and like you say that you want this AI to be cross. Okay. So my point is that after that everything will be negative only. Everything has to come with negative sign. Why? Because like when you are deleting it, like when you are deleting the elements, let's say you delete it like this. So if you reach till AI, so AI would be here, and then would be AI plus 1, AI plus 2, and so on. So of course you cannot delete AI, right? So you will have to delete AI plus 1, AI plus, like if you delete AI plus 1, so this will come with negative sign, and then this will get deleted, and these will get shifted by 1. So now again they are at this position, at second position. So again they will be negative only. So my point is that all the elements after a cross have to be negative. Okay. So we had previously two conditions, that the first element cannot be negative, like it has to be either a plus or a cross, and there has to be only one cross in the entire array, right? And then the third condition that we have third condition that all of the elements after the cross have to be negative, right? Okay. So we have these three conditions, and my claim is that given any array satisfying these three conditions, we can always perform the operations to generate that array. Okay, like what my point is that if an array, like if a configuration satisfies all the three conditions, then I can always generate it using my using the process. Okay, like basically, if my if my first element is a plus and there is one x in the array and all the elements after the x are minus, then I can always generate the array no matter what these elements are. Like whatever there is here, I can always make this. So let's see how. Like let's say I have a plus minus here and a plus here. Okay, so what do I do? So basically these are the first two elements. So since there's a minus here, I can simply delete this one. Okay, so it will become like these will shift, right? So I'll get plus plus cross minus minus. Okay, so I have these two elements now. I can delete this first element. So now this becomes plus cross minus minus. So I have these two elements. Of course, I have to delete this plus, and it becomes cross minus minus. And then I can delete this one. It becomes cross minus, and I can delete this one. It becomes cross. Okay. So like my claim is that starting with a plus, then you can have anything, then a cross, and then only minus. Okay. So if you have something like this, you can always generate an array like this. So this is very powerful, right? Like if you can always generate an array like this, then you can simply try to, like, let's say if you have negative element at this position, then you will try to make it negative, right? Like let's say if you have this array, let's say you have minus 2 minus 3 4 10 minus 9, or let's say you have um, 0 there. Okay, minus 2 minus 3 4 0 and minus 9. Okay, so let's say you decide that you don't take this element. Okay, so this is cross, and after cross you have minus, right? And on the first element there's always a plus, right? Either a plus or a cross as well, like either a plus or a cross. But since cross is here, the cross can't be here. Okay, so on the first element there's a plus, and then there's a cross, and in these two elements you can have anything, either a minus or a plus. It's your wish. So if you have minus 3, like this is negative, so you will make a minus here, and this 4 is positive, so you will make a plus here. Okay, so if you have a cross here, then all the ahead ones are fixed, and in the previous ones you can keep anything. Like for the first element you have to keep plus, and for the other elements you can keep anything. So of course you will keep whatever the sign of the number is. If the number is negative, you will keep negative, and if the number is positive, you will keep positive, right? And you will skill this, like you will have to skill this element. So my entire point is that you can make any configuration which satisfies these three constraints. That there is, like it's starting may there has to be a plus or a cross, and the array has only one cross, and after the cross everything must be a negative. Okay, so this is what the conditions are. But given these conditions, how do we find the answer now? Any ideas? Like if we can set the signs like this, that after a cross there must be all minuses, and before the cross there can be anything except for the first element, there has to be a plus. So how do you solve this now? Prefix suffix sum, like, okay, but how? Probably keep each index as x and find the maximum of all. Yeah, exactly. So you can try that for every index. If you keep that one as x, okay, then what is the maximum answer that you can get? Okay, like, let me show this on a test case. Let's say this test case: 7 minus 6 minus 1 minus 8 minus 8. 7 minus 6 minus 1 and minus 8 and minus 8. Okay, so if you keep this one as x, okay, then all of this will be minus, right? So what is the answer in this case? The answer you will get is like plus 6 plus 1 plus 8 plus 8. So it is 16, 17, 23. Okay, then let's say if you keep cross here, okay, then for the first element you have to keep plus, that is compulsory, right? And then after the cross you have to keep minus, so minus minus minus. So you have 7, and this is minus 1, so plus 1 plus 8 plus 8. So you have 16, 17, 24. Okay, then let's see if you keep cross here. If you keep cross on third element, then on the first one there should be a plus, and for the rest of them it is your choice, right? Either you can keep plus or minus. So of course you will keep minus, right? For this minus 6 you will keep minus because it is negative, right? And then after this one you will keep minus only. So what we'll get is plus 7 plus 6 plus 8 plus 8. So 13 and 16, 29. Then again I keep cross here and plus here, and these two can be anything I want. So I will keep minus minus, right? Because both are negative, and this has to be minus. This has to be minus. So we get 7 plus 6 plus 1 plus 8. So which is 22. And lastly, this can be a cross, and this has to be a plus. And for these three we can choose. So we will choose all negative, because all of these elements are negative. So the answer is 7 plus 6, 13 plus 14 plus 8, 22. And so the answer is 29. So the answer is 29 for this test case, hopefully. Yeah. So this is how you can solve it. But now the only thing is that this is n square, right? Like you will think that when I try one x, like if I keep an x on an index, I'll have to iterate over the entire array to figure out that what is the sum, right? So this is O of n square. But actually you can do it in O of n also. How? So let's say if you keep index I, like you have this array, right? You have this array, and if you keep at index I the cross, okay. So after that you want all negatives, and on the first element you want a plus, and on these two, like all of these elements, you will keep anything, right? You can keep anything. So what will you keep? You will keep whatever the sign is. Like if you have aj somewhere, like this is index j and this is aj, if it is negative, then you will give it minus sign, and if it is positive, then you will give it plus sign. So basically you will add the absolute value of aj, right? Like even if it is minus 3, it will add plus 3 to your sum, and if it is plus 3, it will still add plus 3 to your sum. So basically for all the elements that are on the left of this I, you will have absolute of aj, and which are on the right of this I, you will have minus aj. So like let's say if your ith has the cross, then your answer is what? Your answer is basically plus a1. Okay, so a1 will be with a plus. Okay, then plus absolute value of a2 plus absolute value of a3 up to absolute value of ai minus 1. So up till I minus 1, you will, like, you can take anything you want. So you will take the absolute value, right? And then ai is skipped, and then from ai plus 1 to an, so you will get negative. So minus of ai plus 1 minus a of ai plus 2 up to minus of an. Okay. So this is your answer. If you skip I, if you keep cross at I, then this is your answer. And you can actually write this as the postfix sum. Like this, this is a of I plus 1 to an, the sum, right? So you can simply write this one as minus of postfix of I plus 1. Okay. And you can just keep iterating from I is equal to 1 to n for this cross. And you can just keep this running sum. Okay. So when you are moving from I to I plus 1, you can simply add the absolute of ai to your sum variable. Like you can just keep a sum variable and just maintain this sum right here. And so when you move from I to I plus 1, you can simply add absolute of ai to the sum. Okay. Or you can use prefix sum as well if you want. Like you can simply store the pref of I is a1 plus absolute value of a2 plus absolute value of a3 up to absolute value of ai. So if you use this prefix sum, then it would be just pref of I minus 1 plus post of I plus 1. I mean minus post of I plus 1. If you keep the postfix sum as it is. Okay. So this is the implementation. Okay. Yes. So any doubts in this? I will show the code, and meanwhile you can ask any doubts if you have. In 10, C in n, input the array A, and make the postfix array. So post of I is the sum from I to n minus 1. And I just define this postfix n to be 0. Okay. Postfix n minus 1 to be a n minus 1. And for int I equal to 2, I equal to n minus 2, I greater than equal to 0, I minus minus. Post of I is equal to post of I plus 1 plus a of I. Okay. So my post of I is ai plus ai plus 1 up to a of n minus 1. And initially, like this ans variable is to keep me the maximum. Like I'll keep storing the maximum value in this. Like ans equals to max of ans comma this. And sum is the running sum of the previous. So this sum is the, like I have the sum variable for this thing. Okay. And initially the ans is minus post of 1, because basically this is the case where I keep cross at the first position. Okay. So if I keep cross here, if I keep cross here, then all of this will be negative, right? They would be negative. So in this case, the answer, the sum would turn out to be minus of this sum. So index 0, index 1, index 2 up to index n minus 1. So minus post of 1, right? So answer is minus post of 1. Now if I keep on the cross at I, then I would have post of I plus 1. So sum minus post of I plus 1, that would be my answer. And I'll take the maximum of that. And so then if I'm moving from I to I plus 1, I will add the absolute value of ai to my sum variable. Okay. And then I print the answer, right? Yes, it is the observation which was the entire thing. It was quite easy. Hmm. So if anything, like any doubts before we move on to D? Any doubts in C? Anyone? Huh. Understood. Rating of D. Uh, like 1800, IS 1800 old. You can see on C list. No, I think you should try it first. Uh, just try the program first and then the solution. You can see the recording later, right? So this D, the rating is in progress. Okay. Account is disabled. Yes, for some reason, I don't know why it is disabled. It says skip submissions, but I don't know why it is that way. Anyways, let us move on to the next one. So D is Xmas or hysteria. Franklin is plotting a Christmas attack where he casts the spell Mass Hysteria on a village of elves. There are n elves numbered from 1 to n, where the elf I has a health of HI and attack of AI. Initially, HI is equal to AI for all I, and all AI are distinct. Elf I is alive if and only if its health is positive. When Franklin casts Mass Hysteria, the following happens. Choose a pair of distinct living elves, X and Y, such that elf X has not attacked before. If no such pair exists, then terminate the process. Then elf X attacks elf Y, decreasing HY by AX. Additionally, due to the recoil, HX is decreased by AY. Note that AY and AX remain unchanged. The process will repeat until it is impossible to choose a valid pair of L's. It can be shown that mass hysteria comes after at most n iterations. Given an integer m, construct a valid sequence of attacks that such that exactly m L's are alive when the process ends, or determine that no such sequence exists. Okay. So what they have here is that we have some animals. I will not use the word else because it is hard to pronounce. So I have animals. Okay. So we have n animals. Okay. And basically the ith animal has health HI and attack value of AI. Okay. So what happens is the animal I, when animal I attacks animal J, what happens is HI decreases by AJ. So HI goes to HI minus AJ, and the health of Jth, uh, because of the attack, health of Jth also decreases by AI. So health of I decreases by J, and AJ, and health of J decreases by AI. But the attack points do not get affected, right? So for example, if initially, initially in the input they are saying that HI is equal to AI for all I. So for all the animals, the health points and attack points are same initially. So let's say we have five. Let's say we have some animal one, which has a health point 5, attack point 5, and animal number 2, he has health point 3 and attack point 3. So when he attacks, when one attacks 2, what will happen is this 5 will decrease by 3, so it will become 2. So health point and attack point, health becomes equal to 2, and this health becomes minus 2, right? And the attack point of this remains same. Okay. So basically, this second one becomes dead. It dies. Okay. So now we have to determine that, we have to basically. Okay. So in the process, what happens is, we have n L's, right? Or n animals we have, and we have to choose two animals, X and Y, such that both are alive. First of all, alive means h of I is greater than 0. Okay, health is greater than 0, then it is alive. So we have to choose two animals, X and Y, such that both are alive. And also the health of X, X has not attacked before. Okay, X should not have attacked before, and we have to make X attack Y. Okay, so HY minus equals to AX हो जाएगा, and एच एक्स माइनस इक्वल्स टू ए वाई हो जाएगा एंड सो बेसिकली एक्स विल हैव अटैक वाई in this move. So this is what one thing happens in the process, and we have to basically give them a process such that finally there are exactly uh, m animals alive. Okay, so for example we have here in the first test case we have four animals, one, four, two, and three. So let's say this is health, and attack is also same, one, four, two, three, right? And m is two. So we want that after the process, two animals must be alive, right? So what we can do is we can simply, like, let's say this four attacks the one. Okay. So what will happen is its health will be minus three. This health will become minus three, and this health will become three. All right. And this two attacks this three. Okay. So this health will become one, and this health will become minus one. Right. Or no, actually, now the thing is that if we do this, there is one more possibility, right? Like this animal has not attacked yet, and these two are alive. So now this can attack this, right? So they cannot end the process here. Like the point is that whatever the process is, it has to end. Okay, like we cannot really say that okay, this animal two, one, two, three, four. So this animal 2 will attack animal 1, and animal 3 will attack animal 4. And so finally only animal 2 and animal 4 they are alive. So two animals are alive, and so this is the answer. So this is wrong. Okay, this output is wrong because this one is still alive, right? Like minus 3 and minus 1 they are died. Like they are dead because it is less than equal to 0. And this 3 is already attacked. This 3 has already attacked, so it can't attack once more. But this one, it has not attacked yet. So actually it can attack this 3. Okay. And so what will happen is this one one health will go to um, one health will go to minus 3 because of this 4, and this 3 health will go to 0. Okay. And so finally all are dead. All 4 are dead. Okay. So this is not a correct answer. Like basically whatever answer we give, we want that after all of those attacks, like after all those attacks, there should be no possible attack. Okay, like they are saying here that in the output it should satisfy that after the kth iteration exactly m animals are alive, and there does not exist a pair of distinct l's x and y such that x has not attacked before. Okay, so that's what the question is. Like I just explained the problem right now. So do you get the problem? Like why this is not correct? 2 attacks 1 and 3 attacks 4. Why this is not correct for this problem? I'm not sure. You will get to know, I guess. Okay, so do you get the problem right now? Or is there any doubt in the problem? This is div 2 or like div 1 plus 2. So the first 6 problems are similar to div 2 only. Yeah, so problem is clear. So how do we solve it? Like first of all, there is one thing to notice that okay, first of all, they are saying that the process, it can be shown that the process terminates after at most n iterations. Like at most n iterations can be there after of this process, and after that it has to end after that. Okay, they are saying that. So why is that? Like why is it that the process cannot go more than n times? It is because every animal can attack can attack only once, right? That is the thing. So the process cannot go for more than n iterations. It is not possible. Okay. So at max, only n iterations can be there in a process, right? Also, one more thing is that the process will not end as long as there are at least two alive animals. Like the process cannot end. Process can't end as long as there are, like, first thing, there are at least two alive animals. There are at least two alive animals. Okay. And second thing, there exists. Okay, I'll use this. There exists an alive animal, an alive animal that has not attacked yet. Okay. So basically, if there are at least two alive animals and there is at least one animal which has not attacked and it is still alive, then the process cannot end. Like the process will have to go on. Okay. So my point is that let's say you have 10 animals. Okay. Let's say you have 10 animals with number from 1 to n, or like 1, 2, 3, 4 up to 10. Okay. So actually, is it possible? Is it ever possible that the process just lasts for two turns? Like the process just lasts for two turns and then it ends. Is it possible? No, right? Like if there are 10 animals and right now only two turns have occurred, then definitely there must be someone who has not attacked and who is still alive, right? Like basically, it is pretty obvious that if you have 10 animals and if you have only like done two attacks, then of course at most four animals must be involved in that, right? At most four animals must have been involved in that. So the other six animals can attack, right? They are still alive and they have not attacked yet. So they can attack and so the process cannot end, right? So in general, if I say, in general, if we have n elements, then approximately n by 2 attacks have to happen. Like in any process, at least n by 2 attacks will have to happen. Because if less than n by 2 happens, then there must be some animal. There must be some animal which has not attacked yet. Like which hasn't been involved in any attacks yet. Okay. So that is the point. That um, my like the point is that my number of attacks can't be less than n by 2. Okay, like if we have 10, then even if we attack 4 times, there has to be at least two animals which have not been attacked yet or they have not attacked yet. Like basically there has to be at least two animals which have not been involved in an attack, and so we can choose them, right? So we have to have at least five attacks to end the process, right? And let's say if we have seven, like if we have odd, then basically if we do three attacks, right? If we do three attacks, then the thing is that there must be one animal which is left. Okay, but actually, you can see that it is not possible to do only three attacks. Okay, like my point is that if you have, let's say, seven animals, okay, one, two, three, four, five, six, seven. Okay. So now, like if you do three attacks, let's say one attacks two, and three attacks four, and five attacks six. So now you will say only seven is left, and since only one is left, we can say that the process can end here. But that is not correct because even though only seven is left, Like only 7 has not yet been involved, but there are some other animals which are alive. Like when one attacks 2, when one attacks 2, this 1 gets destroyed and 2 becomes equal to 1, right? And when 3 attacks 4, this 3 destroys and 4 becomes 1. And when 5 attacks 6, 5 gets destroyed and 6 becomes 1, and 7 is remaining. So actually you can still do some attacks. So like my point is that for n equal to 7, you can't end, you cannot end in 3 attacks. Okay, because in 3 attacks it's not possible that everyone dies. Okay, like if you have 7, and let's say even if you involve 6 animals in these 3 attacks, it is not possible that every animal, like every of these 6 animals dies. So at least one of them must be alive. Okay, and so this last animal can attack that one alive animal. Okay, so for n7 you can't end in 3 attacks, so at least 4 attacks you will need to end. Okay, so like for n equal to 10 we saw that at least 5 we need, and for n7 at least 4 we need. So you can see that it is basically n by 2 ka ceiling. Okay, like my point is at least n by 2 attacks will always be there. Okay, my point is that for any process, at least n by 2 ka ceiling attacks will always be there. Okay, and actually we can this is a tight bound also. Okay, my point is that you can always find a process which ends in a ceiling of n by 2 attacks. Like let's say if you have 8, like if you have n equals to 8, right? Let's say 1 to 8, 1 2 3 4 5 6 7 and 8. So my point is that you can always find an attack, you can also always find a process which ends in 4 attacks. Okay, so how do you do that? You can simply do like this. Like you can attack 8 attacks 7. Okay, so 7 dies, then 6 attacks 5, so 5 dies, 4 attacks 3, 3 dies, and 2 attacks 1, so 1 dies. Okay, so these are 4 attacks, and now these 4 are alive, 2 4 6 and 8, but all of them have already attacked, right? So now no one is alive who can attack, so this process ends in 4 attacks, right? So you can always find a process which ends in n by 2 ka ceiling attack. And for odd n, let's say n equal to 7, let's say you have 1 2 3 4 5 6 7. So like in this case, you can always find a process which ends in 4 attacks. So let's say 7 attacks 6, so 6 dies, 5 attacks 4, so 4 dies, 3 attacks 2, so 2 dies, and then 1 can attack anything, let's say 1 attacks 3, so again 1 dies, right? Actually 1 and 3 both die. Okay, but yeah, um, the point is that let's say 1 attacks 3, so 1 and 3 both die, because when 3 attack this 2, its health became 1, right? So when 1 attacks this 1, both of them die, because this becomes -2 and this becomes 0. Okay, so yeah, this process now is end. Like these two are dead, and the alive ones 5 and 7, they're already attacked, so the process ended after 4 attacks, right? So my entire point until here was that for a given n by 2 ka ceiling attacks will always be there. N by 2 ceiling attacks will always take place, right? And my one more point is, in every attack, in each attack, at least one death, at least one death will occur. Okay, like since initially hi is equal to ai, right? Hi is equal to ai is given, and also it is given that all the ais are distinct, right? So let's say if I is attacking j, if I attacks j, and if ai is greater than aj, okay, then the j will die, all right, and otherwise I will die. Okay, so basically in every attack, um, at least one of them will die. Actually, both can die also, because um, like if hi, like it might happen that someone else also had attacked j previously. Like when I attacks j, it might happen that someone else had attacked I previously, or someone else had attacked j previously, and because of that their health is not equal to ai or aj, but it is less than ai and aj. But it is sure that at least one of them will die. Like let's say for I and j, the value of ai is 5, the value of aj is 3, right? So we know that the value of hj is definitely less than equal to 3, right? Because it was initially equal to 3, initially equal to aj, and now it is something either 3 or less than that. So when I will attack j, so 5 is definitely greater than hj. Like basically this ai will definitely be greater than equal to hj, and therefore definitely j will die. J will definitely die. That is my point, that uh, in every attack at least one death will occur. Okay, so we saw that at least n by 2 sealing attacks, n by 2 seal attacks will occur, right? And also in each attack at least one at least one animal will die, right? That is the point. So from these 2 points, what we can say? We can say that at least n by 2 animals will die. Like we can say that at least n by 2 sealing animals will die, right? That is the point. So this entire explanation was to figure out that at least n by 2 sealing animals will die. So for this one statement I explained for whatever 10-15 minutes, but do you guys understand until here? Thank you. Yeah, true. What do you mean by this? So newbie noobex. Yes, if m is greater than n by 2, then -1. Yeah, so at least n by 2 animals will die. So like n minus n by 2 का ceiling, which is basically n by 2 का floor. So at most this much will remain alive. But actually, I what I did was in my code I just counted that how many we have to kill. Okay, like in the problem they said that m animals m animals have to stay alive, have to stay alive, right? But actually, since I'm counting the number of animals that will die, so I just changed m to n minus n. Like I just took the input and set m to n minus m, which is basically my problem becomes that m animals have to die. Okay, so like I just did this change and thought about the problem after that. Okay, so for me, the problem is that exactly m animals have to die, but I figured out that at least n by 2 ka ceiling animals will die. So if my m is less than n by 2 ka ceiling, like in my code, the new m, if it is less than n by 2 ka ceiling, then answer is equal to -1. Okay, yeah. So this condition is correct if the m is original m, but for my modified m, this condition is there. Okay, but if what if not? Like if this m is sufficient, like if this m is greater than equal to n by 2, that is we want to kill at least n by 2 animals, then how do we make the process? Okay, so first of all, just think about how we got n by 2, right? Like I just showed you how we can get n by 2 attacks to happen. So like in this case, let's say for n8, we saw that if we um, take this 8 and kill the 7, so 7 will die. Then 6 will kill 5, so 5 will die. Then 4 will kill 3, so 3 will die. And then 2 will kill 1, so 1 will die. And that's how we got n by 2, right? Because after this, all the animals have either died or they have attacked already, right? So the process ends here. So my point is that's how we got n by 2. So actually, this strategy we can apply here as well. Okay, like how I came up with this, like how did I think of this? Like I'm explaining that how did I think of how to keep n by 2 attacks? Like for even case, let's say for even n, how did I come up with the case where I can get exactly n by 2 attacks? So I thought that every animal has to either die or it has to attack, right? Because finally I want that no animal should be alive and has not attacked yet, right? Like I want that after n by 2 attacks, every animal should either be dead or it has already attacked. Okay, so in every attack A to B, in A to B attack, I want that this B should die and A should not die. I mean A, I don't care about A, but this B should die. So in that case, both A and B would be dealt with. Like A can't attack because A has already attacked. I mean, after I do all the ML operations, after that A would not be able to attack because A has already attacked this in this attack, and B is dead, so it can't attack. So like I just tried to make this such that if A attacks B, then B dies, right? So basically A should be greater than B, right? So like for n equals to 8, I tried this 1, 2, 3, 4, 5, 6, 7, 8. So I tried attacking 8 with 7, 6 with 5. So if 8 attacks 7, 7 will die and this will get 1. Like its health point will get to 1. Then if 6 attacks 5, then the 5 will die. 4 attacks 3, so 3 will die. And 2 attacks 1, so 1 will die. Right? So that's how we can get n by 2. Okay. Okay. So that is one extreme. Like let's say if we have, like if we want to kill n by 2 elements, if we want to kill, let's say if m is equal to ceiling of n by 2, then you can simply do this process, right? But what if m is not equal to n by 2? Like okay, this is one extreme, right? This is the case of one extreme, like m equal to n by 2. So what we figured out that if m is less than n by 2 ka ceiling, then answer is -1. So m can be greater than ceiling of n by 2 and up to n, right? Like m can be up to n and it has to be greater than or equal to n by 2. So like we got the answer of one extreme, right? But what about the other extreme, n? Like in between we can interpolate maybe. Like what I'm trying to do is figure out how to make any answer. So like we got the answer when m is equal to ceiling of n by 2. But let's try to find the answer when m is equal to n. Like if we want to kill all the animals. Or let's just try to find the answer when m is equal to n minus 1. Like actually m equals to n is pretty difficult. So we'll try to find the answer for m equals to n minus 1. That is, we want to kill n minus 1 animals. Okay. So let's say n is something, let's say n is 7. So we have 7 animals, 1, 2, 3, 4, 5, 6, 7. And we want to kill 6 animals. Okay. Then how can we do that? How will we do that? We can simply do that by uh, doing it like this. Like just attack 1 with 2. Okay. So 1 will die and 2 would become 1. Then attack 1 with 3. So 3 would die. Sorry, not 3 would die. This animal would die and 3 would become 2. Then attack 4 with 2. So 2 will die and 4 will, like that's how we'll do it. Basically, if you attack 2 with 1, then 1 will die and 2 will stay alive. Then if you attack 3 with 2, then 2 will die and this will stay alive. Then if you attack 3 with 4, this will die. If you do this will die. Then this will die and this will die. And finally, only 7 is alive and no other animal is alive. So the process ends, right? And so you have killed n minus 1 animals in this way. Like if you have 1, 2, 3 up to n, then you can kill n minus 1 animals in this way. So like if you do from left to right, you can kill n minus 1 animals. And if you do from right to left, you can kill n by 2 animals, right? So now the idea is that you can combine these two operations. Like let's say if you have basically what like if you do from right to left, like if you do from right to left, then you will kill n by 2, right? And if you do from left to right, then you will kill approximately n, right? So this factor of 2 is different, right? This factor of 2 is differing, so you can exploit that actually. Like let's say you have 1, 2, 3 up to m or n, right? So if you do from right to left until the index I, and if you do from left to right until the index I minus 1, so approximately what you will see is n minus I upon 2. Like if you, this is n minus I, right? Here there are n minus I elements, so n minus I upon 2, like okay, it is plus 1, but I'm just doing approximately, so let's do it n minus I only. So if you do until index I from right to left, then you will get n minus I upon 2 animals which are dead. And if you do from left to right until the index I minus 1, then you will get approximately I minus 1. Like correct, because when you do left to right, you get n, or like O of n, like n minus 1 you will get, so I will call it n only. So that's what the idea is, that if you do from right to left, you get a by 2, like length by 2. Yes, I can explain like that. Let's say if you have 1 to n, 1, 2, 3, 4 up to n, and if you do right to left until here, let's say this length is r, and left to right until here this length is l, then approximately you will kill l plus r by 2, right? So if you want to like increase the number of animals, then you can increase l. Like if you increase l by 1, this r will decrease by 1, so this entire quantity will increase, because r has a by 2 as well, right? That is the main idea here. Like we need to find the exact point but approximately we can say that this works, that L plus R by 2, this is the number of animals that will get killed. If you do for L length from left to right and for R length from right to left, so L plus R by 2 animals will get killed. So if you want to increase this quantity, if you want to increase this quantity, then you can move this bar right here. Like you can increase the L and decrease the R. So like this quantity will increase. And if you move this bar to the left, then this quantity will decrease, because L will decrease and R will increase. But R has a by 2 with it, so this term won't increase that much. Okay, so that's how you can make any value between n by 2 ka ceiling to n minus 1. Like see, for what is the corner case? Like if the bar is entirely here, that is, okay, sorry, if the bar is entirely here, that is you are doing the entire range from left to right, then you get n minus 1, right? You just saw you can get n minus 1 that way. And if you like if the bar is entirely here, then you are doing right to left for the entire range, and you will get n by 2 ka ceiling or n by 2 ka floor. Like we'll figure out what is the exact. So that is the corners. So in between of them, any value you can get by just changing this bar. Okay. So approximately we can think of it like this. So do you guys understand this? Oh, sad. This is pretty sad. Yeah, so the main idea here is that you can make any value from n minus 2 a ceiling to n minus 1 just by moving the bar here and there. Okay. So like exactly if I try to understand, let's say we have n equals to um, 9. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. So you let's say what you do is you kill this 9 attacks 8 and 7 attacks 6. Okay. Actually, what you need to do is first attack until here. So 1 attacks 2, 2 attacks 3, 3 attacks 4, 4 attacks 5, 5 attacks 6. Okay. So let's say this is index 0, index 1, index 2, index 3, like 0, 1 up to index I. Like let's say index I tak you do this, right? So in that case, how many animals will die? So in this case, I is equal to 5, right? I is 5. So I animals have died 1 to 5. So while doing this, I animals have died till here. And what is there? So when 5 attacks this 6, 6 becomes 1, right? So we have 1, 7, 8, and 9, right? Like how many are left? N minus I. So n minus I elements, they are left now. And so what you can do is you can attack 9 to 8 like this and 7 to 1 like this. So n minus I upon 2 elements will die, right? So if you do from left to right until I, and then you can so like you will be left with n minus I, and then you can just do from right to left. So you will kill n minus I by 2. So I plus n minus I upon 2. This is what? This is the number of animals you will kill. Okay. So by just varying this I, like by just changing this I, you can change this number anywhere from ceiling of n by 2. to n minus 1, right? So we figured out that for m less than equal to n minus, like we figured out that for m less than ceiling of n by 2, the answer is minus 1. Then for m from n by 2, m from n by 2 up to n minus 1, we figured out how to find the answer, right? We know the answer now. But only one case is left now. What about m is equal to n? What if m is equal to n? That is, we want to kill all the animals. We want to kill all the animals. So, how do we like take care of that? This is the corner case. Like, yeah, you guys were saying m equal to 0. So, that is the case. Like, I have done m goes to n minus n, right? So, for me, m is equal to n is a corner case where I am stuck. So, if we want to kill all the animals, then how do we figure out the answer? Like, can we kill or not? And if we can, then what is the method? And if not, then why not? So let's think of that. Okay. Yes. So actually, while doing this, like while doing this, didn't you guys think that what these are doing? Like, let's say you have n as 7. 1, 2, 3, 4, 5, 6, 7. Okay. So let's say if you make this 1 attack 2, 2 attack 3, 3 attack 4. Okay. So what you will remain is 1, 5, 6, 7. Right. So essentially what these 1, 2, and 3 have done, they have attacked something of a higher value. Right. And essentially they have killed themselves. Like when one attacks 2, this one gets killed, right? So essentially this one has killed itself. Okay, that is what it has done, right? So actually we can kill, like, our point is that we want to kill all the animals. We want to kill all the animals, right? And if this one attacks this higher value element, this 2 attacks this higher value element, then this, like, they are basically killing themselves, right? So it is good for us that they are killing themselves because we want all of them to be dead. So can't we just do this? Like, basically for every element, we want that it should kill an element of a higher value, right? Like if I just make this one kill this two, make this two kill this three, make this three kill this four. So essentially they are, this one is killing itself, this two is killing itself, three is killing itself, right? But this seven, like, how will seven kill itself? There's no way, right? Like if we do kind of do this, then all of these are dead. But finally, this seven is still alive, right? It is still alive and it is still strong. Okay. So how do we take care of that? Now, actually, what we can do is, like, we can try to attack this seven. Like even if this one attacks this, if one attacks the seven, then also this one will kill itself, right? One will die. But then seven will face some health issues, right? Like its health will decrease by one. Its health becomes six, right? Then this two can kill seven. I mean, this two attack seven. So again, two dies because two is less than seven. But six suffers some health issues, so it becomes four. Then three attacks this seven, so it becomes one, and three dies. Then four attacks this seven, so four dies, and this also dies. Okay. So now again we are stuck now, right? What we can do? Because now if you attack five with six, then this five will die and six will become one, and six is the only thing alive now. It is the only thing that is left alive. So what do we actually do? Like what can we do now? So actually, the entire point is that we will only attack 7. Like this is something to think about. Like I don't know how, I don't know exactly how it can come to your mind, but what I thought of was basically, let's try to do this. You will attack, like what you will do is, let's say you want to see this 7 is the only thing that is annoying us, right? This 7 is the only thing that is annoying us because we can't really kill itself. Like this 1 can attack a higher number and it will kill itself. Then 2 can attack even higher number, it will kill itself. But this 7 cannot kill itself, right? Because it is the highest. So someone else has to kill it, right? But everyone else is inferior to it, right? Like if anyone else attacks it, it will still not die. So multiple people have to attack it. Okay. So what I am trying is, let's try to make this 6 attack this 7. Okay, so it has not died, it is still 1. But now let us make this 5 also attack this 7. Okay, when 6 attacks this 7, like first of all, when this 6 attacks this 6 will die. So that is fine, that is good. Now when this 5 attacks this 7, 5 also die. But now this 7 also dies, right? And then again we are left stuck. Like again, the same problem is there. Now how do we kill off this 4? How do we kill this 4? Because now these 3 are dead and 4 is the highest. So how do we kill this? So instead of doing this, we can actually reverse the order. Like we can do these kills like this. So this 1, 2, and 3, they have killed themselves, and 4 also, let's say, it killed itself. And now what we do is, now we will attack 7. Like this 5 will attack 7, and 6 will attack 7. And so this 7 will die, and these 2 will also die. Okay. That is my entire point. Like the entire point is, I want this 7 to die, right? And for that, I will have to take the help of this 5 and 6, right? So if I first attack this 7 using 5 and 6, then these 2 will also die, and this will also die. So how will I kill 4? That is the problem. So what I will do is, before I do this, I will first kill everyone up till 4. Like I will do this first. I will kill everyone up till 4, and then I will attack this 7. Okay, that is the order. The order matters here. Okay, so that is the entire idea, that given my array a1 a2, like a1 a2 a3 up to an, I can simply find out that what are the elements that I can take. Like starting from an minus 1, I want to take some elements such that their sum, like a3 a4 up to an minus 1, this sum has to exceed an, greater than equal to an. So I'll find that point. Okay, I'll find this point, and before that, I'll kill everyone off. Like I will just kill all of them. How? By just attacking the next one. So that's how they are killed, and then I will attack an using all the rest elements. And so when they are attacking an, they will themselves die. And also finally, like in the last attack, only this an will die, right? So this is how. Actually, no, like actually we will have to do it in reverse order. Like first we will, of course, we'll kill off these 2 elements, or like however many there are before this a3. So before this a3, whatever the elements are, we'll kill them off. And then what we'll do is we will start from here. Like we will start from this element, we'll attack an, then we will attack a minus 2 to an, a minus 3 to an, and then we'll attack a3 to an. Like we will do it in reverse order. And why reverse order? Because we want to ensure that this an stays alive till the end. Like we don't want that an dies before that. Like see, my point is, okay, let's say we have 15 as the highest element, then we have, let's say, 6, then let's say we have 4, then 3, 2, and 1. Okay, Or actually, let's keep it 8. Okay, and 1. So my point is that, okay, this is 15. We want to kill it. So we found out the first point, which is at least 15. Like, okay, until here it is 8 only. Then this and this is 12 only. Then this and this is 15. So we have reached 15. So we will use these three elements to kill this 15. But like my entire point is that I want to ensure that until I perform the last blow, this 15 has to remain alive. Because X attacks Y, I cannot do this if Y is already dead. Like if Y is already dead, then I can't do this. Right? Otherwise I would just attack this 15 with 1, then with 2, then with 3, then with 4, then with 8. I would just do that. But and then say so all of them would be dead. But I can't do that. So I have to ensure that like that my Y is alive while I'm attacking it. So what I'll do is these extra elements I will first delete, and then I will attack with 8, then with 4, and then with 3. So this will ensure that this 15 has not gone to 0 yet, because I know that this 3 is the first index at which the sum exceeds 15, right? Like until here, the sum is still less than 15, but only here the sum exceeds 15. So I can do that. Okay. Actually, even if you go from left to right, they should be fine. Like at this index only, the sum should exceed. Like because it is in increasing order, right? So I think at this index it will like it should increase. So both are fine. So yeah, that is how you can deal with the case of n equal to 0. Okay. So do you get this, or any doubts are there? For n not equal to 0, isn't the answer obvious that for every larger element, we'll try to keep it alive and kill a smaller element with it. And for the remaining elements, we will kill them consecutively. Like I don't really know what you mean. I don't understand, but probably you are right. Like I guess you are right. Like I don't know. I don't understand your solution. But what I told you is correct also. There might be multiple cases, of course. So yeah, do you get this? Do you get how to kill everyone? But okay, there is one more case where it is not possible. Like, see what I told you is that A1, A2, A3 up to AN, right? So I want to kill this AN. So I will find the first index until this sum from AI. Let's say let's say it is AI. Okay. So A1, A2 up till some AI, up till some AN. So let's say this AI to A of n minus 1. This is the first index I for which this summation, like sum from AI plus A of I plus 1 up to A of n minus 1, this exceeds AN. It is greater than equal to AN. And so what you will do is you will first of all kill all the elements before this AI by doing this, right? And then from this AI onwards, you will kill off AN. Like you will attack AI to AN, AI plus 1 to AN, and so on. And that's how you will kill everyone. But what if you cannot get this AI element? Like what if you reach till 1? You reach till A1, and then also this AN is still too large. Like this sum is still smaller than AN. Then what do you do? Then in that case, it is not possible. Okay, like it is not possible that you have gone all the way. Like if you have gone all the way from n minus 1 to 1, and still the sum is less than AN, then of course you can never kill the AN, right? Like in no way can you kill this AN. Like even if I tell you that you don't need to kill you don't need to kill anything else. Just kill this an for me. Then also it is not possible because the combined power of everyone else is still less than the power of an. So it is not possible to kill him. So if m is given to be 0, and if this an is greater than the sum of rest of them, then the answer is -1. And if it is not less, then there has to be some index, right? There must be some index at which this sum becomes greater than an, and you will use the elements till that index. Okay, that's the solution. So I hope you understand this. Okay, are there no chats or is it not showing here? Let me search. Okay, there are no chats. So I'll just show the code now for D. And if there are any doubts, then you can ask right now. It is still testing for some reason. Okay. Yeah. So I have int nm seen nm, and I'll just change m to n minus n. I have to kill off m animals, right? Then, yeah, I want the array to be sorted, right? Like I assume that the array was sorted in this, so I just sort the array. Like I just store the value comma index pair, and then I sort the array, right? Then at least seal of n by 2 तो मरेंगे ही. So if m is less than n plus m is less than seal of n by 2, then print -1. Okay. Then the ans vector, which will store the attacks, right? So like they have told to output the attacks, right? So the ans will store the attacks. Okay. So now what we do is, like I will check for which I. Okay. Like if you keep an I, then you can kill off I plus n minus I upon 2, right? So you want this value to be equal to n. Okay. So I just iterated over this I. All right. And also I ensure that n minus I is even. Okay. So I just iterated over all I from 0 to n minus 1. Okay. And then just check if this value is equal to n. So like there must be an easier way, like there must be some way to find the value of I of 1, but I just looped over all I and check if this value is equal to n. And if it is equal to n, like if I plus n minus I upon 2, if it is equal to n, then I just did that. Like I just killed from left to right for j equal to 0 to I minus 1. And for j equal to n minus 1 to j equal to I killed from right to left. Right? That is what I did. And then break. And then if in this loop, like if in this loop I do not find a value of I, then that means my value of m must be equal to n. Like this is the if condition where m is equal to n, right? So now what I'll do is I will just do that. I'll find the sum of the first n minus 1 elements, and if that sum is still less than the last element, then print -1. Okay. Otherwise, I'll find the first element. I'll find the first index where the sum exceeds, right? So this p1 variable is the index at which the sum exceeds, right? Or actually, p1 is the index before that, because this for loop does p1 extra. So basically, from 0 to p1, I want to kill them off, right? So v of I will attack v of I minus 1, and then we like for p1 plus 1 to n minus 1, this vi will attack the last element. Okay. and I just print the answer. Okay. All right. So this was D. I think you have no doubts. So I'll move on to E now. Huh. Okay. After college and is an advantage of CF. Like I don't really know about the, like I am the wrong person to ask this because I'm still in my third year and I don't really have any knowledge about the market situation, that what do companies look for and all. The reason I do CP is because I like it. I do it for fun. I don't do it for jobs and internships. So I don't really know that what is the benefit of doing, what is the point of doing CP. It is for fun. Like for me, the point is having fun. I can't really tell if it has any benefit or not. So yeah. Anyways, let's move to E. While procrastinating at work, Dilhan the elf stumbled upon two arrays A and B. Initially, both of them consist of a single integer 2 to the power k. That is, both the arrays A and B have a single element which is 2 to the power k, where k is a non-negative integer. Dilhan then applied the following two types of operations an arbitrary number of times, possibly 0, in any order. First is flatten, choose either A or B, and select any element x that is maximal within that array. Then replace x with two copies of x by 2 in the same position. The operation can only be applied if x is even. And concatenate, set both A and B to be A plus B, where plus is the concatenation, this is the array concatenation. After performing these operations, Dilhan discards B, hides A from you, and challenges you to a game. Let n be the length of the hidden array A. You can make the following query. Choose an interval L to R, and Dilhan will tell you the sum AL to AR. Find out the value of the maximum element of A by making at most 300 queries. Okay, so like what they are saying is we have two hidden arrays A and B. We have two hidden arrays A and B, and initially both of them have only a single element which is 2 to the power k. All right, and then what is the thing is, like the person, what he will do is either he will perform operation 1 or operation 2. Okay, so operation 1 is what? Operation 1 is he can select any element, like he can select any array, either A or B, and select the maximum element in that array, maximum element in that array, right? And then let's say it is x. So he can split that x into x by 2 and x by 2. So he can delete x and insert these two characters at the same position. Okay. And the x does not need to be maximum in the other array. It has to be maximum in this one, this array only. Right. And second operation is that he can replace both A and B to be A plus B. Okay. So this is what he can do. Like he has started off with these two arrays, having only a single character, I mean a single number, 2 to the power k in both of them, and the same number, right? And he can do either operation 1 or operation 2 any number of times. And basically, um, he can do this. And finally, what he will do is he will discard the array B. Like he will hide the array A from us and he will discard the array B. And we have to figure out that what is the maximum element maximum element in array A, right? This is what we have to do. And how do we figure that out? We have to, like, we have some queries. Like, we can ask some queries. That is, we can ask that L to R, what is the sum from L to R? Sum from L to R. Okay. This is what we have to do. This is the task. And we have at most 300 queries to solve this. 300 queries. Okay. So how do we solve this? Now, basically, like, I did not really solve this in the contest. Like, as you can see in the standings, I couldn't solve it during the contest, so I asked for a solution. And like, it is pretty simple actually. To be honest, I should have thought of it. But the thing is that there is just one observation which you can do, and after that it is very easy. Okay. So like, the observation is that the observation is that after the operation number 2, like, when the Ilhan performs operation number 2, that is concatenates A and B, A and B both become same, right? This is the observation. Like, this is pretty obvious. Like, this is obvious, right? That once operation 2 is applied, that is both A and B replaced with A plus B. So they both are same now. They both are A plus B, right? So they both have the same elements, same number of times, equal number of times, right? Okay. So what do we do of that? Now the thing is that operation 1 can only be applied on the maximum element, right? Like, let's say you have the array A. Let's say you have the array A as something like 1, 2, 2, 4, 2, 2, 1, like this, something like this. Like, I don't know if it's possible to make or not, but let's say you have it, okay. Or actually, it is not possible to make this. Let's Okay, let's assume that it is possible to make it. But anyways, so let's say you have this array A, and the array B is also the same. Okay, 1, 2, 2, 4, 2, 2, 1. Right. Now, if I tell you to apply the operation number 1 4 times on the array A. Okay. Like, if I tell you to apply the operation number 1 4 times on the array A, then what choices do you have? Like, the operation 1 can only be applied on the maximum element, right? So if you want to apply it to this array A, then you will have to choose this 4 and decrease it, right? Like, you have to choose this 4 and split this into 2 and 2, right? So that is one time you apply. You have to apply 3 more times. Like, you have to apply 4 times, right? So now the maximum element is 2. So you will split this 2 into 1 and 1. You will split this 2 into 1 and 1. And you'll split this 2 into 1 and 1. Like, you can choose any 3 twos. I just chose these 3 because of no reason. But my point is that the 3 twos will become 1 and 1. Like, first of 4 will become 2 twos, and then um, the 3 twos will become 1 and 1, right? 6 ones. The 3 twos will become 6 ones. So like, when we did this, the length of the array increased by 4, right? Like, when we split this x into x by 2 and x by 2, so the array length increased by 1, right? When we apply the operation number 1 a single time, the array length increased by 1, right? So when we apply the operation 4 times, the length increased by 4, right? But my entire point here is that um, if you want to apply an operation on this array some k times, then it is fixed that on what numbers you have to apply the operation. Okay, so you can observe that if I apply the operation on this array x1 times, and I apply the operation on this array x2 times, like on a I apply x1 times and on b I apply x2 times, and initially a and b are same, right? So my point is that if you apply less number of times, like if x1 is less than x2, then actually you can comment that the maximum, like the maximum element will be there, will be there in a. Like let's say for example, if we have 1 2 4 4 4 2 1, like this, both a and b are this, a is this and b is this, 1 2 4 4 4 2 1. Okay, and let's say you perform the operation twice on this array and 3 times on this array. Okay, so if you do 3 times on this array, all three of these four, like all three of these fours will become 2 2. So 2 2 2 2 2 2, right? And on this one, if you perform 2 times, so only these two fours will become 2 2. So 2 2 2 and 2. So basically now the maximum value is 4, right? Like among these two arrays, the maximum value is 4, and it is only in A. Like it is only contained in A, because I had to do the operation on this array less number of times. Like only 2 times I had to do the operation on this array, whereas on this array I had to do it on 3 times. So I am saying that on whichever array you apply the operation less number of times, you will get the maximum element on that array. Okay, but how is it helpful? Like how is this helpful? So the thing is that you can observe, like now if I concatenate these, like let's say now I concatenate these two arrays. First of all, just observe that doing this, like doing this option number one, doing this doesn't change the sum, does not change the sum. Okay, that is one observation. So like initially, if a and b, if a and b are same initially, so their sum also same. So sum of a is same as sum of b, right? So if you like split these, like do the option number one any number of times on these arrays, the sum will still remain the same, right? So like if you concatenate them, like let's say you concatenate these two arrays, okay, so what will happen? It will become 1 2 2 2 2 2 4 2 1, and then this is the array A, and the array B is 1 2, then 6 twos, right? And then a 2 and a 1. So this is B. So this is the entire array now. So my point is that since these two arrays had the same sum, like this also had the sum of, let's say x. So this also had the sum of x, and now you concatenated them, right? You concatenated them. So this part has a sum of x, and this part also has a sum of x. So like if I give you this array, if I give you this array, you can easily figure out that which part is from which array, right? Like you can simply say that this total sum is 2x, right? So whatever the point is, like at whichever point the first sum appears, that is your first array A, and the second sum appears, like at whichever point the sum becomes x, that is your part of array A, and at whichever point the sum becomes x from the right hand side, that is your array B, right? So actually you know that which part came from array A and which part came from array B. And you also know that the maximum value of this entire array lies in the array, like either it is in A or it is in B, right? But which one is it in? So it is in that one in which we applied the option less number of times. Like in A, we had applied it twice, and in B, we had applied it thrice. So actually, we can say that um, we'll find the maximum in A only, right? But then, how do we figure out that how many times have we done, like twice or thrice? So what you will see is each time you do the operation, like if you do the operation twice, then the length of array will increase by 2, and if you do it thrice, then length of array B will increase by 3. And initially, since A and B were same, so the lengths are also same. So whichever one is longer, that is the array on which the operation has done more number of times. Like among A and B, whichever array is longer, that array is the one on which the operation 1 has been done more number of times. So definitely we will find a maximum in the other one. Okay. So like let's say for the samples, like in this samples the array is 1 1 1 1 2 2 2 1 1 2 2, right? So the array is 1 1 1 1 2 2 2 and 1 1 2 2. Okay. So the sum is what? Sum is 4 plus 6 10, 10 plus 6 16, right? So 4 and 4 8. So this part must have come from A and this part must have come from B. And so since we know that, so this is longer, right? Like this has length 6 and this has length 5. So definitely more operations must have been done on A. So we will find a maximum on this B array. Like even though in this case both of them have the maximum, but definitely if there's only one array which has the maximum, it will be B. So we will check on this B now. So this B has sum of 8, right? B has 8 sum. So this becomes 4 and this is 4. So this array must have been made by this A and this B. And since this has the longer length, we will find a maximum in this array. So basically we will find our maximum value in the shorter array. Okay. So we can simply do a binary search. Like we can ask for the sum L to R, right? We can ask L to R and ask for the sum from L to R. So what we will do is we will find the point. Like first we will ask for 1 to n. Okay. And then we will find out the point like 1 comma mid, such that the sum from 1 comma mid becomes equal to the sum from 1 to n divided by 2, right? So we will find that point. So we will have divided the array into 1 comma mid and mid plus 1 comma n, right? And whichever one is shorter, like either one of these two will be shorter, and we will find a maximum in that array, right? Because the one which is longer has been done, like the one which is longer has gone through more operations than the shorter one. So therefore if we have to find the maximum somewhere, it would be in the shorter one, right? That is the entire logic. So this was the solution for E. I guess it should be fine. Like my entire point is that if you start from A and B and they are same initially if A and B are same, now if you perform operation number 1 on A, if you perform x1 times, and on B if you perform x2 times, and if x1 is less than x2, then definitely you will find a maximum in A. Okay. So after you concatenate these two, you will find the maximum of the array in the first half. I mean, not the first half. You will find it in the left part, such that this is the divider where sum is equal both sides, right? Like this part is from A and this is from B, and you will definitely find the maximum in A because if its length is shorter. So whichever part's length is shorter, you will go to that half, right? And this will take at approximately log square in queries, right? Because um, at each step the range is getting less than halved, right? Because if you are at n, you are dividing it into a plus b, a and b, right? Where a plus b is equal to n, and you are going into the shorter one, the smaller one. So at max it can be of n by 2, right? So n ka n by 2 हो गया. So it can only happen log n times, right? And in each iteration you have to find out the middle position, right? So to find it out you need to do binary search like this. You will find the sum from 1 to mid. So you will do a, like you can do a base on this mid, and that will also take log n iterations. So approximately log square iterations it will take. Can I code this? Okay, like I can show the code. I have a code of someone else, so I'll show that. I didn't implement this. Yeah, so this is the code. I'll copy it into my VS Code. Okay. Yeah, so they have defined a function which is solve. Okay, like um, I'll rewrite this code a little. Yeah, this is the code. Like basically in main he has int t c int multi minus minus, and so this code. So int n c in n, and total equals to query of 1 to n. So I query 1 to n, and what we do is, okay, this variable is not used. So yeah, we just call this solve function. This solve basically finds out the, like it takes in the range L to R and the total sum. Okay, and it finds out the middle element via binary search. Okay, so like um, LL low is equal to L, high is equal to R, and answer is equal to low. While low is less than equal to high, if like we will query L comma mid. So if query of L comma mid is less than equal to sum by 2, ans equals to mid, low equal to mid plus 1, else high equal to mid minus 1. So this is the binary search by which we are finding the index for which the query for L comma low, I mean L comma ans, becomes equal to ans plus 1 comma R. Okay, and so if the length, like L to ans, if that length is less than equal to ans plus 1 to R, then I will find, like I'll call the function recursively for L to ans and sum by 2. Otherwise I'll call the function recursively for ans plus 1 to R. Like, do you guys get this actually? Like I think there might be some doubts left, so you can ask. Can I get to 1900 till June 26th? That is a very subjective question. Like that depends on how much you practice and all. So it is possible definitely, but it's only possible if you work hard and practice a lot of problems on code forces, and not just DSA based. Like you have to make your brain work. How much work have I should do to reach expert? So basically, to reach any rating X, you have to be comfortable with the problems having the rating X or X plus 100. Okay, that is the main thing here. That if I throw any problem at you, which is of rating 1700, and you are able to solve it, then I think you will be able to reach that rating of 1600. Um, like not all, but I guess at least 90% of the questions you should be able to solve. So you have to practice that rating and that rating plus 100 also. Like you have to ensure that you are comfortable in that. Like even if the solution doesn't strike immediately, it should strike within like 30 minutes of thinking about it. That is what comfortable means. Okay. Um, yeah, like that is the point of solving. That's the point of absolving the contest, so that you can see that what else you would have done differently, and you will learn something new. So yeah. Anyways, this was the stream. Okay. If you have any doubts about any problems, then you can ask. Yeah, that's fine. Like just keep absolving, keep absolving, and it's you should be able to solve more problems in the upcoming contests. Wasted 2 hours in D. Yeah, like D was kind of tough also. Even I wasted 1 hour 15 minutes in that. No, first was Div 4. I think my first contest was Div 4. Uh, Maybe Goodbye was after that, but yeah, around 1 year it has been. Like in December, I started PCDs. Thank you. Anyways, let's end this then. Thank you all for joining in. Good night, everyone. I'll see you later. Bye bye.